Hi friends, in today's lecture we are going to learn about the different logical connectives. So we are going to learn in detail about the logical connectives that we have discussed in the previous lecture. So we have learned the logical connective not, and, or, then, if, then, denoted by arrow sign, and then if and only if and only if, denoted by bidirectional arrow. So we have discussed in the previous lecture about these logical connectives, that how we can use these logical connectives to create a proposition or a statement. So we can use these logical connectives in compound propositions. Now today in this lecture we are going to learn about the detail that how this logical connective works. So first of all, let's understand about the logical connective not. So suppose we have the input A, and for that input suppose we have value true and false. So if you apply the not logical connective, that means if I write not A. So friends, I have already discussed that the not operator, not logical connective, is denoted by the tilted sign. So this is the sign of not. So if I write the not A corresponding to the values of A, then the value will be reversed. That means true will become false. And if you apply the false, and if you apply the not before the false, then it will convert it to true. So it just converts the value from true to false, and if the value is false, then from false to true. So it just invert the value, whatever the value in the form of true or false or 0 and 1. If the value is 0 and you apply the not, then it will be converted to 1. And if the value is 1 and if you apply the negation not, then it will be converted to 0. Similarly, if you apply the negation on true, it will be converted to false, and if you apply the negation on false, then it will be converted to true. So this is how the not operator works. I hope you all have understood. Now the next is and. For that I write here A and B. We are taking two inputs, and you know that the values are like true, true, false, false, and here true, false, true and false. If we apply the logical connective and, then we can write A and B. So you know that this is the symbol of and. So if we AND the two inputs A and B, so if the values are true in both the inputs, then the output will be true. So the output will be, for the first input true, true, it will become true, true, false, 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 true, false, and false, false, false. So if you apply the AND logical connective, then it will be true only if the both inputs are true. So if the value of A and B both are true, then only the value will be true, otherwise the all rest of the values will be false. So this is how AND logical connective works. So for all the inputs, if all the inputs are true, then only the output will be true, otherwise false. If any of the value is false, So here you can see that the input for A is true, but the input for B is false. So the resultant will be false. Similarly here, one input is false and for B it is true, but the result is still false because we need the both input true, and here both the inputs are false, so resultant will be false. So this is how the AND logical connective works. Then the third one is OR. So here I am writing for both these inputs OR. So I can write A or B. So you know that OR is denoted by V shape. So this is the symbol of OR. So in OR, if any of the input is true, then the resultant will be true. So here both the values are true. So obviously the value will be true. Then here one of the input is true, so value will be true. Here one of the input is true, so value will be true. And here both the, as you can see that the both inputs are false, so the resultant will be false. So if I talk about the OR logical connective, in OR, if any of the input is true, then the output will be true. This is the how OR logical connective works. I hope you all have understood about NOT, and OR. Now let's move to the if then. So let's see how it works if then. So suppose we have two inputs A and B, and if we apply the if then, for that we can write A implies B. So this arrow is the symbol we use for if then. So let's take some input. So here I am taking true, false, and here true, false, true, and false. So friends, you can see that each time we are taking four inputs: true, false, true, false. Why? Because the total number of inputs are 2. So the formula for the input is 2 to the power, here I am writing 2 to the power n, where n is the number of inputs. So here we are using 2 inputs, so we can put 2 to the power 2. It is equal to 4. That's why we are taking 4 times we are taking the value true, false. Okay, now if you apply the if then, let's see how it works. If then says that if the first input is true and the second input is false, then the output will be false. So for this only, because you can see that the value of A is true and value of B is false. Here we are using A implies B. So we are using A implies B. So whatever input is before the arrow should be true, and after the arrow it should be false. Then only the output will be false. So here the output will be false, and for rest of the others the output will be true. So this is how the if then works. So if we are using A implies B, then the false output you will get only for the true and false pair. I hope you all have understood. And if I write like this, B implies A, then you can see that for B implies A, we again need true and false pair. So you can see that the B is this is B. So true and false. So for this input, true, for B we need true, and for A we need false. So true, false, then it will be false. For that pair only the value will be false, output will be false, and for rest of them the value will be true. So this is the truth table for if and then. I hope you all have understood how if then works. You have to only remember that it should be in the form of true and false. For only true and false the value will be false. You can see here, for true and false the value will be false, otherwise other values will be true. So this is how if then works. Now the last one is if and only if, denoted by so you can see that this is the if and only if. Let's see the truth table for if and only if. So we are taking two inputs A and B, and here we can write A if and only if B, if and only if. Alright, so again we are taking some inputs like true, true, false, false, true, false, true, false. So if and only if says that for same values, same input values, the output will be true, and for different inputs output will be false. So here you can clearly see that for this particular input pair we have the same value true, true, and here we have the same value false and false. So for both these inputs the output will be true, and for rest of them it is false. So if the inputs are same, then the output will be true, and if the inputs are different, then the output will be false. This is how if and only if works. So we have understood these logical connectives not, and, or, if then, and if and only if. Now let's understand one more term, that is well-formed formula. So we are going to learn what is a well-formed formula. In short we write WFF, well-formed formula. So what is a well-formed formula? It is an expression, so I am writing here, it is an expression consisting of atoms, or you can say symbols, parenthesis, and logical connectives. So this is the definition of well-formed formula. For example, let's see some examples of well-formed formula. If I write a relation A and B and C plus R. So this is a relation, and if I ask you whether this particular expression is a well-formed formula, so the answer is true. Why? Because in well-formed formula, the atoms, two atoms cannot come without a logical connective. So you can see that between these atoms A, B, C, we have already learned that atoms are nothing but symbols that we use for proposition. So here you can see that all the atoms A, B, C are connected with logical connective AND. So this is a well-formed formula. This is a well-formed formula. On the other hand, if I write like this, A and A, B and C. Now if I ask you whether this is a well-formed formula or not, so the answer is false, because you can see that A and B, these are the atoms, and we have used without logical connective. So we cannot use two atoms together without any logical connective. So we must need a logical connective between the atoms. So this is not a well-formed formula. Not a well-formed formula. So friends, I hope you all have understood what is a well-formed formula. Again I repeat, it is an expression consisting of atoms, parentheses and logical connectives. So you can see that we have used the atoms. So these are the atoms A, B, C, and we have used the logical connectives and parentheses. So this is the formula of, this is a well-formed formula. Now to solve a well-formed formula, later on we will discuss how we can solve a well-formed formula. We use the precedence rule. So always we need to follow the precedence rule to solve or simplify a well-formed formula. So priority, let's see the priority or precedence. Precedence of logical connective. So the first one is not, then, and, then, or, then, if then, and, if, and only if. And the order is like this: highest to lowest. So first of all we will solve the not logical connective, then and, then or, then if then, and then if and only if. You cannot solve or before and or and before not. So we need to follow the priority of logical connectives while solving any expression. So this is very important, students. Keep in mind that this is the precedence. So friends, this is all for today's session. In the next lecture, we will learn about other gates like NAND, NOR, and we will learn how we can simplify a well-formed formula. So that's all for today's session. Thank you. Have a nice day. Bye.